Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 368, largest divisible subset. This problem is based on dynamic programming and has been asked in companies like Google, Amazon, Microsoft and many more. And in this video, my focus would be more on understanding the concept than just solving it. It's marked as medium. Let's have a look on the problem statement. Here in this problem, we are given a distinct positive integer array nums. A positive integer array is given to us with all unique elements and then return the largest subset answer such that every pair in that subset is satisfying this condition. The condition is, let's say if we are picking any pair in that subset, one should be dividing other completely. Answer: either the ith is divisible by jth or jth is divisible by ith. And whatever is the maximum subset, you have to return that. If there are multiple solutions, return any one of them. Okay, just to keep it simple, we will be given an integer array with all unique characters, unique elements, and from that array we have to form a subset such that in subset every pair, not just any one or two, every single pair is following this condition, any one of these condition. Either the first item is divisible by second or second item is divisible by first. So if I just try to prepare a subset, and after that what we have to return is whatever is the largest subset you can form, you have to return that. So let's say if I just pick 3 in my subset, what is the next other element I can take? If I'm taking 3, I can't take any other element because 4, 2, 8, none of the item is divisible by 3 and none of the item is dividing 3. If there was a 1, so I could have taken 1, but in this case I can't take anything. So let's skip it. So with 3, the subset I can make following this condition is of one size. If I take 4 here, then what is the next element I can take? I can take 8 as well. If I'm taking 8, 4 is dividing 8. In every single pair, one item is dividing the other completely. Can I take 2? Yes, I can take 2 as well, because in this case, whatever pair I will take, 3 item will form how many pairs? A, B. First item we have possibility of 3, then 2, which is 6. 6 pairs we are going to form, and in every 6 pairs, one item will be dividing other. If I taking 4 is dividing 8 and 4 is divisible by 2. If I taking 8 is divisible by 2. So 6 is the permutation. So for combination we have 3. A, B. So okay, in this case every pair is satisfying this condition, so it's a valid subset, and this subset can be the candidate to my answer, and I will just capture it and see if I can go better than this. No, there is no other possibility, so this is going to be my answer in this case. If I take an example something like this, 1, 2, 3, 4, what can be the largest subset? If I take 1 is always valid. If I take 2, this is also valid, and because every pair is following this condition. If I take 3 is not valid because 3 is divisible by 1, but 3 and 2, if we pick a pair 2 and 3, it is not valid pair. So we can't take 3, but we can take 4, because in this case every 2 pair is dividing, one is dividing other completely. Even if we take 2 and 4, it's valid. 1 and 4, it's valid. 1 and 2, it's always valid. Okay, let's say if I take example something like this, 1, 2, 4, 8. In this case, what is the answer? The whole array I can take as a subset, because every 2 pair is satisfying this condition. One is divisible by other, the other is divisible by 1. So here, if I take a pair of 4 and 8, I can directly check. What I can do is, I can see that the bigger one, if I take the bigger one, whether the bigger one is divisible by smaller one, I can check this condition instead of always. Let's see whether A is divisible by B or B is divisible by A. I can directly check this condition. So I will just check for every pair A and B, where A I will keep as a bigger element. So if I just take a pair something like this, 2, 4, I will take it like this. 4, 8, I will take it like this. See, you are getting an idea. 1, 2, you're getting an idea that I'm taking elements in a order. First one is smaller, second one is bigger. So if we have to take up this condition, if we have to check for every pair satisfying this condition, what I can do is I can convert this problem statement into like this. Firstly, I will be sorting this array 2, 3, 4, 8. If I sort this array, the condition will become something like this. Firstly, you are picking any element I, and after that you are picking any element j, and it should follow this condition. Not this condition, I think, firstly there is I, second there is j, so j is always bigger, so it should follow this condition. J is divisible by I equal to 0, right? So we have reduced this statement, this condition, to single one. If we just sort the nums array 3, 4, 2, 8, our nums array was 3, 4, 2, 8, right? In this case there was two conditions, either I is divisible by j or j is divisible by I. But to remove the confusion, what I have done is we can easily sort this array n log n time 2, 3, 4, 8. If I have sorted it, I have to pick a pair A, B. If I pick A first and then B, then definitely B is greater than A. In this case, I can directly check. If B is at index j, A is at index I, so index j divisible by index I is equal to 0. If this is the case, I can easily pick j after I. Let's say once I have picked 2, then what can be the possible j? For every j which jth item is dividing I can pick that j if I is fixed. Okay, so this condition we can use while filling our subset. So you can pick one I, and for I, for the corresponding j, if you want to take, you can pick in this manner, that if j is dividing I, you can pick. Otherwise you can skip things as well. See, now let's try to form our array. We have 2, 3, 4, 8. 2, 3, 4, 8. What I have to do is like figuring out the pairs, the set where every pair is going to follow the condition. See, let's say if I pick 2 and 3, if this pair is not satisfying. If I pick 2, 4, this pair is always satisfying the condition. So firstly I am picking 2, then I am picking 4. 4 is bigger, so 4 is divided by 2. And how I can pick? Let's say initially I picked 2. So what I will keep in mind that the last element I have picked is 2, and if I have to pick the next element, it should be divisible by last element, right? So let's say I have picked 2. I recently picked 2, then I come to 3. 3 is not divisible by 2. I can't take it in the set. 4 is divisible by 2. I can take it. And if I take it in the set, it will be like this. 4 I have taken. And what about the next element? See, every single pair should be following the condition that jth item is dividing I completely. It means that if this 4 is divisible by 2 and the next item is divisible by 4, then this condition is going to be satisfied. Transitive property. If A is dividing B and B is dividing C, then A is dividing C as well. So in this case, what I will do is I will just capture the latest updated element in the set. So latest updated element in the set is 4, and now I can pick elements on the basis of 4, because 4 is already divided by 2, so there is no need to check the previous elements. Just consider the 4, and let's after 4, if there is only one element which is 8, I will just check whether 8 is divisible by 4 completely or not. If it is true, getting 0 as a remainder, then I will just pick 8. It means this 8 is divisible by all the elements in this set. In this case, in this property, I can pick elements. See, okay, now we have understood the intuition. Let's try to build our answer. 2, 3, 4, 8. So 2, 3, 4, 8. This is the set after sorting. So first step is sorting. Arrays dot sort whatever is the given array. After that, what I can do is, for every element I have two possibilities. First one, to take that element. Second one, to do not take that element. If I am taking that element, let's say this is the set. If I am taking 2, it should be divisible by the previously added element. But previously there is no added element. It means for the first item, I can blindly add in the set. There is no need to check. But let's say, how can I add 3? We will add 3 if 3 is divisible by the previously added element. Previously added element is 2. So I will not consider 3. So when I come to 4, I can take 4 only if it is divisible by previously added element. Previously added element is 2. 4 is divisible by 2. I can take 4 easily. Right? For every ith element, I am just checking the previously added element. So for all of these index starting with 1, 2 and -1, I have that element because there will be at least one element in the set. But what about the first item? For first item, you can assume that the previous value was 1, and you'll just see whether the number is divisible by 1 or not, because this condition is always true. That's why we don't have to worry about the case. So the take option is taking if the current element is divisible by previous, then take it. When we cannot take it, we can't take it in any case. Whenever, it's totally up to your mood. If you don't want to take it, don't take it. Okay. So after taking the current element, we might get a list of subset. After not taking the first element, from the remaining element, we might get a subset. Right? So 2, 3, 4, 8. 2, 3, 4, 8. If I'm on the first element, if I take 2 in my set, what I have to do now? 3, 4, 8. And the previous item is 2. So this is my problem statement. In this case, I can assume that the previous element is 1. So this is my statement. If I do not take 2, I just directly come to 3. 3, 4, 8. And the previous item is 1. This is my problem statement. If you try to analyze, this is our P, the biggest problem. And this is our smaller problem after one step. Smaller problem. You can directly see the nature of those two problems are same. So problem and subproblem is same. So you can use recursion. So we definitely use recursion in this case. When the problem is same, the constraints are getting lower. So this is the definition of recursion, and it is getting satisfied. So use it. And don't forget to explain it to the interviewer in the interview. So interviewer is always expecting justification before your every single step, except some interviews like Meta. Okay, so in this case, my problem statement is you are given an array 2, 3, 4, 8, where the previous element is 1. You have to pick elements in such a way that the current element is divisible by the previous one. Current element is divisible by the previous one. So this condition is also simplified after doing the sorting. So yeah, all the problems are same, and in this case, directly use recursion. Then we will see whether we can memorize it or not. And to get recursion, what I'm going to do is, like, my problem will be something like starting from index I. You are given an array nums. In that nums array, starting from index I, whatever the previously captured element, just return me the list of subset, which is the maximum. Okay, so this is my problem statement. So if I just try to see why I'm writing like this, taking some parameter, returning some value. Because let's say after some time, if I realize that okay, I need to memorize these calls, that will be easy for you. You form a key using parameters, store this value. Okay, so if I just write a solution function, let me keep all the constant thing global. So nums, let's say nums is global, n is global, n is the size of this nums array. What is not global is index and previous element. And what I'm going to return is list of integer. See, now this is something I have understood. But after some time, let's say if I'm not take element, not take n3, not take 4, not take 8, I will be left with empty array. Maybe previous element can be anything. Just let me know what is the maximum subset you can get. Maximum subset we can get from the empty array is definitely empty string. So that will serve as a terminating case or edge case for our problem. If id is equal to n, return new list, empty list, return empty list. So this is my terminating case, edge case you can say. Then you have two possibility. One possibility, you are taking ith element, you are not taking ith element. If you are not taking ith element, so whatever is the result from the subsequent call, which is idx plus 1, and what is the previous one? Previous will remain same because you are not taking any element. Then anti list, not taking list, t list. Let's say this is t list, this is anti list. If you are not taking, you are getting this list. If you are taking, see, we can take only in this condition if value at idx is divisible by previous. If this condition is satisfied, then we can take it, otherwise we are not going to take it. So then what is the result? Whatever is the result. So let's say I'm taking a list, temporary list, and in the temporary list I am adding the current element, right? So if you are taking it, add the current element and add the elements from the subsequent call. Adding the current element, and I'm going to add the element from subsequent call like idx plus 1. What is the previous now? Previous will be updated in this case. So whatever this case, this will also be added to the t list, take list. So now my template is ready. This is my edge case, and this is my condition where I am taking the ith element, when I am able to take the ith element, when I am not able to take ith element. So we get only two options. At index 0 we get any two options. Index 0 we get only two options, either take 2 or do not take 2. So this function call is solution. Whatever is the biggest size biggest size subset from our array starting from index 0, and the previous element is 1. Why previous element is 1? So that for the first time when we are adding an element in the subset, we'll be able to add it there without any filtering. So this is the biggest problem. Biggest problem will be this: for whatever is the nums array starting from the index 0 and go till the index n minus 1, just give me the answer. So for the biggest problem, I'm making couple of subsequent call. This is the subsequent call, this is the subsequent call, subproblems, and in the end, whatever is the maximum list, return maximum list. Maximum list is not taking and taking. Whatever is the maximum list, just return that. If we just directly take the time complexity of this recursion, it will be order of 2 raised to power n, right? But here we can see the index value will go from 0 to n minus 1. And what is the previous value? What can be the previous value? For that we have to take up the constraints. Item nums I. Nums I can be anything. Nums I can be anything, so it can be anything. It can be going till maybe order of let's say m. m is the size of the previous element, n is just the index. And what can be the value of n? N is going till 1000. N is till 1000, but the number previous element can be till 10 to the power 9. So if we just take a multiplication of that, 10 to the power 3 into 10 to the power 9, so we'll have around quadratic time. Quadratic time if we are able to memorize those codes. And we will definitely be having overlapping subproblem. How? Let's say we are skipping 2. If we are skipping 2, I'm getting this state. Now let me show you how the problems are getting overlapped. See, this is the array. And for the first time when we are picking the first element for our subset, we are assuming that the previous element is 1 because 1 is dividing every single element. So for the first time, let's say I am taking 1. If I take 1, so 1 will be added to my subset. And the remaining array will be 2, 5, 7 with previous equal to 1. This is the problem. And now if I just don't take 2, it will be like this. 1 is my previous element, 5 and 7 will be the array, right? And now if we just take a different case when we are not taking 1. If we are not taking 1, 2, 5, 4 with 1. If we are not taking 1, again we are getting the same problem. If we are again not taking 2, 1 is the previous element, 5, 4. This is the array. So here you can see that even if we are taking 1, I'm getting this problem, I'm solving it. I'm also solving this problem. But after some time, I'm getting this problem again. So this is already solved. If the result was somewhere stored in some cache, I could have directly used it. And this problem is also we are getting again. So there are overlapping subproblems. So whatever is the number of subproblem, how can be the possible subproblems? For any number of any value of previous integer or any possible index. So this I can use. So here definitely we can do the memorization, and see the memorization is not that difficult to implement. The more important is you are understanding the recursion. Just this is the edge case, and edge case is order of 1 time, correct? And after edge case there is some pre-processing where we are making subsequent call. So before pre-processing, just check in cache. Just check in cache that you have already solved it or not. If you have not already solved it, just do the pre-processing, but make sure you are storing in cache before returning. Before returning, you are storing it in the cache, so that in other case, if we are getting the same set of parameters, same problem we are getting, we will be able to read it through the cache. Okay. Now I will be writing the code for this, and you can just go along with me to see how the code is going to be looking like. And here, if we do the memorization, the time complexity is increased from exponential to quadratic. Quadratic is like total number of possible indices, total number of possible value of previous. So this is the time. And what about the space? Are we taking any extra space? No, apart from this recursion tree, I'm not saying any extra space. Okay. Are we taking any extra space? Yes, we are taking any extra space to store our resultant list. And this list can go around order of n. So order of n time we are also taking. And what about the sorting? See, sorting is in parallel to this. Sorting is in parallel to order of n into m. And that sorting is n log n time. But overall this is dominating. So this will be the time complexity. Now let's code this approach. Let's start writing the code. First of all, let me take it in the global integer. N is the size of this list. This dot nums is equal to nums, and n is equal to nums dot length. Okay, we have initialized the stuff, and I will be writing a helper function, which is the biggest problem. Like in this nums array starting from index I, what is the subset of largest length which is following the condition given the problem statement, like this. And for that I also need to pass a previous variable that we discussed, because every item we are picking based on the condition that it is divisible by previous one. And we came to this approach after sorting. If we do not sort, then our problem set, our conditions are 2 in number, can be anything. But if we sort it, it will be something like this. Answer J will be divisible by I. Okay, so for that, directly sort it. Arrays dot sort nums. Okay, now the problem statement looks good, and whatever is the answer, just return directly. Solution 1 and 0. Let's write the helper function. Private list of integer. This is my solution function. Integer idx and integer previous. What is the terminating case? If idx is equal to 0. If we do not have any element to take, our subset will definitely be empty. In this case, directly return. See, it should not be list of integer, it is list of integer. Return new array list. Okay, so this is my terminating case, and now I have two possibilities: take I, take index, or not take. If I am not taking it, then what is the result? List of integer and t, not take. List is equal to solution of idx plus 1, and previous will remain same. I will take it only in one condition: if nums of idx is divisible by previous. This condition is required, and if this condition is satisfied, I will be taking this take list or not. Anti list, list of integer, take list is equal to, let's say it is empty in the starting list. If it is empty in the starting, if I can take the current element, just take the current element, list dot add nums of I, and add the remaining element as well. What are the remaining element from the subsequent call? That is solution of idx plus 1, but in this case previous will be updated, nums of idx. So here take list dot add all from subsequent calls. So this is the taking possibility, do not take it, and whatever is the maximum, that we have to return now. Now how do I check the maximum? Just compare the list size. Take list dot size is greater than anti list dot size. If take list is greater, then return take list, otherwise return not take list. Now this is my helper function. Sorting, find the biggest problem. Now the biggest problem is going to be having the answer like this, with the help of subsequent calls, idx plus 1, previous idx plus 1. Whatever is the bigger one, just return it. This is just recursion. Let's see if it is working fine or not. Giving me wrong answer. Why wrong answer? Because output is 0. What can be the issue? Okay, the edge case I have not written properly. Edge case should be index when index is reaching n, last index plus 1, and n I have already stored. Let's run again. Okay, test cases are passed. If I try to submit it, it is exponential 1, so it should definitely give me TLE. Okay, we got TLE. So how do we optimize it? Just memorize it. This is the input and this is the output. If you are getting input multiple times, just store it. And how do we store this input? I'll just create a key and value, key value pair. For the key value, we definitely use map, where the string can be the key and the value is list of integer. This is my map, and let's initialize the map as well. Map is equal to new hash map. This is the pre-processing. This is the processing part, and before the processing we check string key. First of all, prepare key idx plus, let's say, space plus previous. This is my key. If map contains key. If the key is already present in the map, just return it from map dot get key. If the key is not present, then do the processing. After the processing, whatever the answer you're getting, just store it before going. And map dot put whatever the key value is t-list. In this case, map dot put whatever the key value is not take list. Okay, I have taken memorization map, and then edge case is order of one time, so don't worry about that. Storing checking the cache, otherwise doing it, processing it, and then storing it in the cache before returning. Let me submit again now. Just checking on sample test cases. Okay, I have done a mistake. There is one more error as well. Sample test cases are passed. It means our approach is working fine. Let's see how the memorization has helped us. Now this time it is successfully submitted, and here we have avoided overlapping subproblems, calculated multiple times with the help of this map. And I have just done this memorization in a straightforward way. Key value pair, just store the key, whatever the key you are getting, just store it and retrieve it. If you have any other approach, let's discuss in the comment section below. Thank you guys, bye bye.